welcome back. We're in a new section now. So we just finished talking about absolute values and how to solve equations with absolute values. We're going to put those on the back burner. We will come back to those. But this section is all about solving inequalities. So instead of having like 5x equals 7, it might be something like 5x is less than 7. How is that different? What does it mean for our answers? That's what we're going to be exploring in the next couple, well, maybe 3 videos. We'll see. So, I figured we would take on the first 3 examples that are in the note sheet that I put on Canvas for you. And the very first one is a word problem. And you know me, I'm just going to keep throwing word problems at you. And every time we do one, we're going to get a little more comfortable with how we do it. And I might sound like a broken record, but for this first example, what are we going to do? We're going to read it slowly. We're going to write down important information as we come across it. And if it would help to draw a picture, we can draw a picture. So, example 1. Javier has at most $15 to spend today. Right? So Javier's got at most $15 to spend. He could spend less. He could spend exactly $15. The important thing is he can't spend more than that. So, can spend up to $15. Okay, cool. He buys a bag of pretzels and a bottle of juice for $1.59. Holy cow. What a deal that would be, huh? This example might be a little dated. I think that would set you back a little bit more than $1.59 now. But that's what it says. So I don't think it's important what he bought. I think the important bit here is he spent that much money. He spent $1.59. So, even before reading the rest of the problem, if he could spend up to $15 and he's already spent $1.59, he now has less that he can still spend on whatever else he needs. Let's continue. If gasoline at this store costs $2.89 per gallon. Okay, gas costs $2.89 per gallon. So every gallon, $2.89. How many gallons of gas to the nearest tenth of a gallon can Javier buy for his car? There it is. That's what we need to know. How many gallons? Okay. So we've actually got all the information we need right here. I never have to pick up my note sheet again and look at the problem. I've got everything I need here. The thing is, we have to be able to use all this information to set up some math so that we can figure out the answer to this question. And there's so many different ways of doing it. There's so many. From a common sense standpoint, you could say, okay, he had up to $15 he could spend. He already spent $1.59, so take that out from 15, see how much you have left. And if gas costs $2.89 a gallon, just keep adding on $2.89 for every gallon until you hit however much money he has left. You could do that. The thing is, I think it asks to the nearest tenth. So that might get you into a little trouble if you just added $2.89 over and over again. So we might want to set up some kind of equation or inequality to represent the situation that we're in here. Or I guess the situation that Javier's in. So let's set up 2 sides. So like an equation is 2 sides with an equal sign in between, right? Something equals something. But if he can spend up to $15, we already said that he could spend all $15, or he could spend less. So, if we want $15, to be on one side of this, if we put an equal sign here, that would suggest that he has to spend all of it. But he doesn't have to. He can spend less than $15 or all of it. So instead of an equal sign, I'm going to turn this into a less than or equal to sign. What we're going to put over here is everything that he buys. That has to cost less than or equal to $15, which is how much he started with. So that's how we're going to set this up. We're going to set it as an inequality. Everything he buys has to be less than or equal to $15. So, what goes over here? Well, he already spent $1.59. It doesn't matter what he bought. That's not going to go in this inequality. All that matters is how much he spent. So $1.59. And he can also buy some gas, right? And we're going to take the cost of the things he already bought and add to it how much gas costs. How much does gas cost? $2.89 per gallon. So if I just put $2.89 there, is that what we need? Because, I mean, we can add these two things together. That's definitely less than $15. But how's that going to help us answer the question? We need to know how many gallons of gas he can buy. So it's almost like there's something we don't know that we need to solve for. In algebra, we usually write things we don't know as letters, right? The thing we need to know is how many gallons of gas he can buy. Every gallon costs this much. So 1 gallon costs $2.89. 2 gallons cost $2.89 times 2. 3 gallons cost $2.89 times 3. So the number of gallons needs to be multiplied by $2.89. And I'm going to call that G to stand for the number of gallons of gas. So, this is our inequality that represents this situation. If he starts with $15, he can spend up to that much. He already spent $1.59, and every gallon of gas costs $2.89. All we need to do is solve this inequality, get G by itself on this side, and we'll be able to answer this question. So, how do we solve this inequality? Well, the trick is, at least for the first few steps, we're just trying to get G by itself. It's the same thing as if this were an equal sign. Don't even let it bother you that this is not an equal sign. Treat it the same way. We're just trying to get the G by itself. So let's move this over here first. This is a positive 159, so we subtract. These are going to cancel out, which is exactly what we want. All we have left here is 2.89G. And that's less than or equal to, you would take out 15 minus 159, it's going to be 1341. And you can use a calculator there, you can use the app on your phone or whatever, if you don't know that. Getting that G by itself, one more step, we divide by 2.89. Right? We need to divide here because this is 2.89 times G. To move that 2.89, we have to do the opposite of multiplication, which is division. 2.89s are going to cancel out. That leaves us with just G here. G is less than or equal to 1341 divided by 289. I need a calculator for that one. Or my note sheet, since I've already worked this out. But I would just type this in on my calculator and get 4.64. 4.64. So, what's the answer? How many gallons of gas can Javier buy to the nearest tenth? Remember, tenth is the first decimal place here. So since this is 4.64, this 4 is going to round down to 0, and this is 4.6. So, if Javier had 15 bucks, went inside Ricker's and spent $1.59, and gas costs $2.89 per gallon, we set up our inequality, get the G by itself, and find out the answer is he can afford 4.6 gallons of gas. By far, the hardest part of this problem is setting up this inequality. But like I said, this doesn't have to be the way you do it. If you can just think of it in your head somehow differently and do something completely different than this and still get this answer, that's fine. As long as you show me how it works. You can't just be like, 4.6. You gotta show something, right? But setting up an inequality like this and going through solving it is a good warm-up to what the rest of the examples in this section are going to look like. So, the other two examples we're going to do today, these two, but right here, they're not word problems, they're more basic. So, we can go straight to having an inequality like this and solving it. So, let's see how one of those looks. This one. So, example 2 wants us to solve. Let's show you what it looks like in the notes. It's the same as what I've got. There we go. 4y minus 3 is less than 5y plus 2. Graph the solution set on a number line. We'll talk about what this means when we have our answer. I'm just going to rewrite what's here, this inequality. Okay, so again, in terms of solving, which is what it's asking us to do, that means we want to find out what number the letter in this problem is equal to. So we want to, well, not necessarily equal to because it's an inequality, but we want to get y by itself. So if we've got y's on both sides, one of these y terms needs to move to be with the other one. We want all the y's together. We could move the 5y over here, but we would have to subtract 5y from both sides. And if you can look one step ahead, if we subtract 5y from this, we're going to get negative y's. That's going to make our lives a little more difficult later on. So, my general rule is if you've got terms with a letter on the opposite sides, take the smaller one and move it over to the bigger one. So we'll take this 4y, and since it's positive 4y, we need to subtract it to move it over. Subtract 4y. These are going to cancel out, just like we wanted. This is negative 3 less than 5y minus 4y is 1y, or just y, plus 2. Okay. All right. Our goal, we now just have one thing that has y in it, which is good. We want this y by itself. So now this 2 needs to move over here. And since it's a positive 2, we subtract 2. Those are going to cancel out this time. Negative 3 minus 2 more puts us further into the negatives at negative 5, less than y. So we have negative 5 is less than y. So we now have y by itself. We've got this. We want to graph the solution set on a number line because this actually means a lot of different things. Y could be a whole lot of different numbers that makes this true. Before we graph it, we're used to seeing something like this with the letter on the left-hand side. Notice our y is on the right. That's okay, but if we want to move it to the left, let's just imagine we take this inequality and just flip it backwards so that the y is on this side and the negative 5 is on this side. Notice how this symbol is opening up towards the y. If we flip it around so the y is on this side, it still has to open towards y, so that means we actually flip the sign also. I think this will be easier to graph if we flip it around this way. Okay, just a general rule of thumb, you usually want your letter to be on the left side, and that's fine. We just flipped it around. So we want to graph this on a number line. So the number line is just a horizontal line here. This is the number that's interesting to us in this problem, so this is the number I'm going to put in the middle. Okay. If you've had teachers in the past that always told you to put 0 in the middle of their number line, I suppose you could. You could just put -5 over here somewhere. But if this is the number we're interested in, might as well put it in the middle. Now, we want to show on this number line all the different numbers that we can plug in for y that make this inequality true. It's more than just one. So, at -5, since that's the number that's here, we're going to put a circle here. And since this is a greater than sign, is y, if we plug in -5, does that make this true? If we plug in a -5 for y, is this true? No. -5 is not greater than -5. Those are the same number. So, since this is not true, when we plug in -5, we're going to keep this circle open. We're going to keep it open. You might already know you would fill this circle in and make it a solid dot if this weren't a greater than or equal to sign, because then this would be true. But since it's not, we're going to keep that circle open for now. Well, we're going to keep it open forever for this problem. Now, are we going to shade from this circle? Are we going to shade everything to the left side of -5 or everything to the right side? The arrow shows you the way if your letter is on the left side. So this is another benefit to writing it with the y on the left side. See how this arrow is pointing to the right? It's telling us to shade all the numbers over here. So I usually shade and put like an arrow to this side, making it very obvious that I shaded over here. Okay. So if y is greater than -5, then that means all the numbers to this side of -5 make this inequality true. What's a number that's over here? Like 0. 0's over here, right? If we plug in 0 for y, this becomes 0 is greater than -5. That's true. So it's a solution. It turns out, if we keep going further this way, every positive number also makes this true if we plug it in for y. So every number greater than -5 gets shaded on this number line. And we're done. We have our solution and we graphed it. So there's just one more example for today's video. And you can see it down there. It's multiple choice problem 1. I've copied it here. Which graph represents the solution to 6x minus 2 is less than 5x plus 7? Now, this question is actually asking the same thing as this one. It's just that the inequality is different. I could have written solve here, but since it's multiple choice and you can see the graphs down there, if you do all this, you can match your number line to one of the answer choices. But you will need to solve this just like we solved this one. So I'm actually going to give you a shot here. I would want you to pause the video, go ahead, copy this down on your piece of paper, and see if you can get the x's together and then solve for x like we solved this for y. And see if you can come up with one of the answers. Even if you get stuck, that's fine. I want you to at least get it started. And who knows, you might surprise yourself and get it. So go ahead, pause, come back when you've got what you can. How's it look? Just copy down the original inequality here. I wanted all my x's on the same side, so I took the side with the smaller number of x's and moved it over by subtracting because it was positive. So we got 6x minus 5x is just x. Brought down the minus 2, the less than sign, and the 7. To get the x by itself, we add 2 to both sides because this was a minus 2. Those 2's canceled. We're left with x on this side. 7 plus 2 is 9 on that side. Now, for this one, we didn't have to move it around like we did here because the x is already on the left. So this was really the inequality. So, I know it's not the case in the number lines that are down here that you have to choose from, but if I were drawing my own number line for this inequality, 9 would go in the middle. It would be an open circle because this is just a less than sign. There's no equal to under it. And the arrow is pointing to the left, telling me every number to the left of 9 is the solution. So that's where it's shaded. So which of those number lines matches that one? It is letter A, right? Yes. I had to check and make sure. This is number line A. So, I hope by going through these 3 examples, you've learned a little bit more about how to solve inequalities. They're actually very similar to solving equations. We've treated these inequality symbols essentially the same as equal signs so far. That will change. We've got more examples in the next video or 2. But I don't want you to be scared about the fact that these look different than just equal signs. We're treating them mostly the same. And hopefully you are getting more and more comfortable, especially with word problems like this. If you can just write the information down at the beginning, that's a great start. So, we'll see you in the next video. Have a great day.